This is an exam question taken from the 2019 statistics paper, the AS paper. Two parts to the question, with two parts to the second question. First part being, well, for only 1 mark, so it should be very brief, whereas we've got 5 marks available for the second part, so expect to do a little bit more work later on in the question. So a fair 5-sided spinner has sides numbered 1, 2, 3, 4 and 5. The spinner is spun once and the score of the side it lands on is recorded. So write down the name of the distribution that can be used to model the score of the side it lands on. Okay, so the important word here is fair. So it's a little bit like a dice. On a dice you've got 6 sides. You've got 1, 2, 3, 4, 5 and 6 as the numbers, and they're all equally likely. But we're using a spinner this time. It's only got 5 options on the spinner, but like a dice, they're all equally likely. The probability of landing on one of those 5 numbers all the same. So this is a uniform distribution. So for 1 mark, that's the word they're looking for. You could also write discrete, because you can only have the numbers 1, 2, 3, 4, 5 and nothing in between, but uniform is the word they're looking for. Okay, so this spinner is spun 28 times. The random variable capital X represents the number of times the spinner lands on 2. So we've got a number of trials, so that's 28, all independent. So every time you spin this spinner, it makes no difference to the score. Each time you spin it, it's independent. So the success in this case is landing on a 2. And the probability of landing on a 2 is 1/5 or 0.2. So what we can say is that my capital X has a binomial distribution, number of trials n being 28, and the probability of success in each trial is 0.2. Now the first part here is find the probability that the spinner lands on 2 at least 7 times. So at least 7 means minimum 7. So we want to find the probability the spinner lands on 2 7 times, 8 times, 9 times, and all the way up to 28 times. So we are looking for the probability that the random variable is greater than or equal to 7. Okay, so these are cumulative probabilities. Yeah, I'm not looking for the probability that x equals 7. Yeah, so it's that's just an individual probability, so we'd use a probability distribution function for that. We're looking for the probability that x is greater than or equal to 7, so we need to use a cumulative distribution function. Now you could use the formula booklet. I'll just show you in here. The formula booklet shows you cumulative distributions for binomial random variables. And then you've got different values of the number of trials and different values of the probability of success. However, we can't use this table this time because number of trials 25, number of trials is 30, don't have 28 in there. So I need to go over to my calculator. Now the calculator will show you probabilities much like the formula booklet. So if you see here again, I'm looking for numbers in this table when the probabilities are less than or equal to a certain x value. And that's what the calculator does too. So I need to rewrite this as 1 minus the probability that x is less than or equal to 6. So if you think about that for a second, if I can have 7, 8, 9, 10 all the way up to 28, the only numbers I can't have are 0, 1, 2, 3, 4, 5 and 6. Yeah, so number of trials being 28, also discrete. So you can have anything between 0 and 28. If I want the probability that the number of successes is more than or equal to 7, it's 1 minus the probability that the number of successes is less than or equal to 6. So this is the probability that I want to find, and I'm going to use that on the calculator. So my function, so if we come over here, function on the calculator. So I need to press menu because I want to move from using the calculator function over to using the distribution function. So I can scroll or press the number 7 and equals. I don't want normal probabilities, I want binomial probabilities, but not the probability density function, I want the cumulative distribution function. So from this menu I press 1 and I'm going to get the variable, so that's going to be 6 in this case, where the number of trials is 28 and the probability of success is 0.2. And if I press equals again, this is my probability, 0.6784 to 4 decimal places. So 1 minus 0.6784, putting that in your calculator will give you an answer of 0.3216. Okay, right, so that's the first part, so part 1 of part B. And then in the second part of the question, we are asked to find the probability that the random variable x is between 4 and 8, and I'm not allowed to include 8. Okay, so I want to know the probability the random variable is either 4, 5, 6 or 7. Okay, so again we need to formulate this in terms of cumulative probabilities that we can use the calculator for. So the probability that my capital X value is between 4 and 8 is, now let's think about that, 4, 5, 6 and 7. So if I do the probability that my random variable is less than or equal to 7, but that's 0, 1, 2, 3, 4, 5, 6 and 7. I'm not allowed to have 0, 1, 2 and 3. So I'm going to subtract the probability that my random variable is less than or equal to 3. So think about that again. 0, 1, 2, 3, 4, 5, 6 and 7, but not 0, 1, 2 and 3. So just 4, 5, 6 and 7. Okay, so back over to the calculator. So here I am, again on the calculator, binomial cumulative distributions. My variable needs to have the value 7 first. Number of trials is still the same, and the probability of success is still the same. So my probability for that is 0.8182 to 4 decimal places. And I'm also going to need the probability that I'm less than or equal to 3. And that one is 0.1601. And that's my calculator finished with. Now I'll just show you how to get back out of this. So press menu again, and you can scroll over to 1 or just press the number 1. It will take you back to the calculator. And so my answer, if I plug these numbers into the calculator, 8182 minus 0.1601 is 0.6581. And that concludes the question. So if you'd like to find out more about discrete probability distributions, head on over to studywell.com.